Welcome to this elementary statistics lesson on discrete random variables. In this lesson, you will learn the definition of a discrete random variable, which is a review from earlier lessons. You'll learn attributes of discrete random probability distributions, and you will learn to calculate the mean, median, and variance and standard deviation of a discrete random variable. Recall that a discrete random variable is one that can only take on certain incremental values. The result of a die toss is an example of a discrete random variable, as is the number of people in a crowd of people. A discrete probability distribution is a tabular or graphical display of the probability that a random variable will take on any particular value of x. Discrete probability distributions link each possible value of the random variable occurring with the probability of that value occurring. For example, remember the 2 coin toss experiment from Module 7. In the 2 coin toss experiment, there are 3 possible outcomes for the number of heads tossed: 0, 1, or 2. The probability is 25% for tossing either 0 or 2 heads, and the probability of tossing 1 head is 50%. The probability distribution is shown here. On the x-axis are all of the possible options for the number of heads, and the y-axis reflects the probability for each of those options. Discrete random variables have a mean, which is referred to as the expected value. The expected value of a random variable A is denoted E of A. E of A is calculated by summing the products of each possible value for the random variable and the probability that the random variable will take on that value. This is described by the equation E of A is equal to the mean of A, which is equal to the sum of each value of A times P of the corresponding value of A. Let's look at an example. Imagine a certain breed of fish, of which as many as 4 fish could be placed together in a tank. However, fish owners have observed that the fish tend to fight with each other as more coexist in the tank. The table shown gives the probability distribution for the number of fish that can live peacefully in a tank. To calculate the expected value, multiply the probability by each possible number of fish. In this case, the mean of the probability distribution, mu f, is equal to the sum of each value for the number of fish times the probability for that value, or 1 fish times 50% probability, plus 2 fish times 30% probability, plus 3 fish times 15% probability, plus 4 fish times 5% probability. Thus, the expected value is 1.75. This indicates that the expected number of fish who can coexist in the tank is somewhere between 1 and 2, typically closer to 2, or 1.75. It's also possible to calculate the median for a discrete random variable. This is the middle value. In other words, the median is the value for which the probability that A is greater than that value is equal to 50%, and the probability that A is less than that value is equal to 50%. Sometimes more than one median can be computed, in which case the median of the sample is the average of the 2 medians. Let's consider our fish in the tank again and calculate the median of the sample. What do we expect is the median of the sample? We know that the mean is 1.75. Let's try a median of 2. Is the probability that the number of fish is greater than or equal to 2 equal to or greater than 50%? The probability that the number of fish is greater than or equal to 2 is 0.3 plus 0.15 plus 0.05, or the probabilities of the number of fish being 2, 3, or 4. This probability is equal to 50%. What about the probability that the number of fish is less than or equal to 2? In this case, we sum the probabilities of having 1 or 2 fish, which is equal to 0.5 plus 0.3. This is equal to 80%, which is greater than 50%. Thus, 2 is a median for the sample. Another possibility appears to be having 1 fish, because the value for 1 fish is equal to 50% itself. What's the value that the probability of the number of fish coexisting is greater than or equal to 1? This probability is equal to the probabilities for 1, 2, 3, or 4 fish, which is equal to 100%. What about for the number of fish being less than or equal to 1? This is just equal to the probability of 1 fish, or 50%. So 1 is a median. Recall that if there is more than one median computed, the median of the sample is the average of the two medians. Thus, the median of this sample is equal to 1 plus 2 divided by 2, the average of 1 and 2, or 1.5. It's also possible to calculate the variance of a discrete random variable. The variance of a discrete random variable is computed in a manner similar to any other data set. The equation for the variance of a discrete random variable is the sum of the square of each possible value of the random variable minus the expected value for the distribution times the probability for the given random variable value. The standard deviation of a discrete random variable is the square root of the variance, just as with any other distribution. Let's look at an example. We're back to our fish in the tank. Recall that the median of the sample is 1.5 and the expected value is 1.75. We will need this to calculate variance. Now, calculate the difference between 1.75 in each of the values for the number of fish. Square that difference and multiply by the probability of that value occurring. Sum each of these probabilities together for each value. This is equal to the square of 1 minus 1.75 times a 50% probability plus the square of 2 minus 1.75 times a 30% probability plus the square of 3 minus 1.75 times a 15% probability plus the square of 4 minus 1.75 times a 5% probability. So the total variance is equal to 0.79. Recall that the standard deviation is the square root of the variance. The square root of 0.79 is equal to 0.89. This is the average distance from the mean for this probability distribution. Let's look at our fish again. The probability distribution for the fish is shown here. The mean is 1.75. The median is 1.5. The standard deviation is 0.84. How do we interpret this? A probability distribution is a tabular or graphical display of the probability that a random variable will take on any value of x. A discrete probability distribution links each possible value of the random variable with the probability of that value occurring. This is reviewed from earlier in the module. The expected value of the discrete random variable is the mean of the distribution. Looking back at our distribution, we know that our mean is 1.75. This means that the distribution is skewed toward lower values in the distribution. We also know that our median is equal to 1.5. Recall that the median is the probability, is the value for which the probability of having a variable value greater than or equal to that value is 50%, or less than or equal to that value is 50%. The median is lower than the mean. This means that while the values are clustered low in the distribution, there's a few high values that pull the mean of the distribution up. The standard deviation represents the variance of the distribution. The standard deviation is 0.84. This means that there is quite a close clustering to the mean or median. In fact, the standard deviation added to or subtracted from the mean or median gives a value of 1, 2, or 3. So it is highly unlikely that the value of the distribution is greater than 3. This is reflected in the distribution you see here. It is important to review the definitions of mean, median, and variance for a discrete random variable distribution, and to understand how to apply these equations in context. Although you typically work with continuous distributions most of the time, these equations are valuable and should be understood. Take time to copy these equations and to work each of the problem set questions